Okay, well today we're going to talk about reducing fractions again, but today I'm actually going to give you the shortcut for the way we did it yesterday. So let's cover how to do it. Let's review last time just a bit. Last time we used prime factorization and found all the factors that it had in common and then divided it by all those different factors. So let's review that real quick. So let's find the prime factors of 12. I'm going to do this using the factor tree. So that's 6 times 2. 2 is prime, so I can circle that one. 6 is 2 times 3. 3 and 2 are prime. Remember our prime numbers we need to memorize: 2, 3, 5, 7, 11. 36. We're done. We got all those prime numbers, so we're going to go on to 36. 36, that's 4 times 9. You can break that 4 up into 2 times 2. Both those 2's are prime, so we're done there. 9 is 3 times 3. We're done there because both 3's are prime. So the factors of 12 are 2 times 2 times 3. You can see I like to clump all the 2's together and then clump all the 3's together. So 36 is 2 times 2 times 3 times 3. You should remember this from last time. And we had this is a common factor, this is a common factor, and this is a common factor. You cannot circle a number more than once. So then we did 12 over 36, and we divided it by 2 over 2. That got these common factors, and that gave me 6 over 18. We divided it by 2 over 2 again. That made these common factors, which gave me 3 over 9, and then divided it by 3 over 3. And this is 1 over 3. That gave me those common factors. And 1 over 3, that was my answer. Now I told you I was going to show you the shortcut. We're actually going to do most of these steps. We're going to add one more step, but I'm going to show you how it makes a shortcut. And what we do is we use the greatest common factor. Alright, using the greatest common factor. And I'll show you how it makes it a little bit shorter. So let's find the greatest common factor of 81 and 18. But real quick, what is the greatest common factor? The greatest common factor is the largest integer that divides without a remainder in a set of integers. So what is the greatest common factor? We're going to use the factor tree or the loop EL to find it out. So let's look at 81 and 18. First, let's break it up. We're going to use prime factorization to find all of its factors. All of its prime factors anyways. 81, that is 9 times 9. Each 9 can divide 3 divided by 3. And remember, 2, 3, 5, 7, 11. Those are the prime numbers we're looking for. 9 is 3 times 3, so we got all of our prime factors. So 81, its factors are 3 times 3 times 3 times 3. 18, well that's 9 times 2. 2 is prime, so I'm done there. And 9 is 3 times 3. So 18 is 2 times 3 times 3. Well, if we line these up like we did last time, let's change my color here to make it stand out. How about orange? We have 81 and 18. And here we have 3 times 3 times 3 times 3. Here we have 2 times 3 times 3. Well, I have common factors here. I have common factors here. And so, to find my greatest common factor, I take the numbers I circled and I multiply them together. So let's take it from just the 81. We take 3 times 3. I have 2 3's in common, so 3 times 3. My greatest common factor is 9. Now let me show you how that helps you. So let's try this. Last time we saw that we had 2 3's in common on the last slide. So we could have gone divided by 3, divided by 3, and that is equal to 6 divided by 27. And then they had the second 3 in common, so divide by 3, and that's equal to 2 over 9. And then I'm done. Using the greatest common factor allows me to do this. Let me change my color so it stands out. Oh, okay, that works. Divide it by, what's 3 times 3 we said was 9. That's my greatest common factor. Divide by 9, and that gives me 2 over 9. So instead of having to do 2 steps or 3 steps or 4 steps where I keep dividing by those common prime factors, I can divide by the greatest common factor and only have to divide once. And that gives me my answer. So let's try some more and see how it goes. So we need to find the greatest common factor between 50 and 70. Well, let's do 50. Let's use the loopy L this time around. Remember, those numbers are 2, 3, 5, 7, 11. 2, 3, 5, 7, 11. This is even, so I can divide by 2. 50 divided by 2 is 25. I can't divide by 2, it's not even. 3 does not go into 25. 5 does go into 25, and that gives me 5. 70. I can divide by 2 because it's even. That gives me 35. I can't divide by 3. I can divide by 5 because it ends in 5. That gives me 7. 7 is a prime number, so I'm done. So I can have these loopy L's here. So 50, the factors are 2, 5, and 5. 70, the factors are 2, 5, and 7. So I have some common factors here and some common factors here. What I'm going to do to get for the greatest common factor, the greatest GCF, greatest common factor, is equal to 2 times 5. 2 times 5, the two numbers that we circled together. So that's equal to 10. So to reduce my fraction, I can go 50 divided by 10 is equal to 5. 70 divided by 10 is equal to 7. And that is my fraction reduced. Let's try another one. 8 and 20. So let's divide. 8 is even, so I can divide by 2. That gives me 4. 4 is even, I can divide by 2. That gives me 2. Since that's a prime number, I am done. My loopy L. 20. 20 is even, so I can divide by 2. That's 10. 10 is even, so I can divide by 2. That's 5. 5 is prime, so I'm done there. So my factors of 8 are 2 times 2 times 2. My factors of 20 are 2 times 2 times 5. So I have common factors here, and I have common factors here. So my GCF, my greatest common factor, is 2 times 2, which is 4. So then I can divide 8 divided by 4 and 20 divided by 4. 8 divided by 4, that is 2. 20 divided by 4, that is 5. And that is completely reduced. Boom shakalaka. There we go. Alright, so that is all we got. Hopefully this makes sense. If not, feel free to ask me questions tomorrow, and I will see you then.